situation here that requires our immediate attention. Dr. Mayman has been working on the problem and he's going to fill us in.
3 days ago, astronomers observed a large object hurtling toward the Earth at over 60 kilometers per second.
That sounds serious.
We've calculated the mass of the object to be approximately the size of a small house.
House? Excuse me, is anybody doing anything about this?
That's exactly what we're here to talk about.
For the most part, objects like this burn up when they enter the Earth's atmosphere. They rarely reach the ground.
But is anybody doing anything about this? I mean, look at us. We're all just sitting here, and this thing is coming at us at what, 1,000 miles a second?
Would you please pull yourself together?
We are all going to die. It's going to get awfully hot.
Right. I've been told we have images of the object. We're going to go ahead and put it up on the big screen.
What do you know about comets and meteors?
We build spacecraft here that go to outer planets and comets and asteroids and things like that. And here's an example of one here that's going to go to a comet called Wild 2. This is a quarter-scale model of that spacecraft. It's going to collect some particles from that comet, bring them back to Earth, and we can look at what a comet is built of. We've designed this material known as aerogel, and it goes into this grid, traps the particles, and then this part of the capsule comes off the spacecraft and it comes back through the Earth's atmosphere, and that's how the particles are brought back to the Earth.
This is an outer space simulator. It's an almost perfect vacuum. And in here, we have a piece of dust. We're studying how it behaves in solar wind. By comparing what happens with a piece of Earth dust to what happens with a piece of space dust, which we hope to get soon, we can learn more about what the solar system was like 4.5 billion years ago. It's all in here. This is a replica of Skylab, an orbiting laboratory that was flying during the 1970s. Now, about that time, the sun became more active. More particles streamed off of it, more solar wind. That heated the Earth's atmosphere up a little, and it swelled a little. Skylab started dragging through the upper atmosphere. Eventually, the air slowed it down so much that it fell to Earth. The whole thing was going so fast that most of it burned up in the Earth's atmosphere. This big chunk ended up in Australia. See how the ends are burned and charred? It's a human-made meteor. Don't worry, though, it didn't fall on a dog or anything. When you see a rock fall out of the sky and land on the Earth, you know it's a meteorite. It turns out that both of these are from Mars. This is how we know. Forgot the rock. We placed the rock here in a scanning electron microscope. Close the door and pump all the air out. Then we shoot a beam of electrons at the surface. And by measuring the electrons that are knocked loose, we can generate this magnified image. Now, at the same time, the electrons make these X-rays. By measuring those, we can figure out exactly what chemicals the surface is made of. Like here's oxygen, silicon, calcium, and iron. Now, doing the same type of analysis trapped in the rock, we figured out that it's a mixture of gases that's exactly like the mixture of gases in the atmosphere of Mars. Not the atmosphere of Earth, the atmosphere of Mars. We have to go to a lot of trouble to do this kind of analysis. But after we do, we know almost for sure that we're looking at a rock that came from another planet. Woo!